So it's time to move from this memory-based data management, which is definitely not that great because data gets erased whenever the server stops and restarts. It's time to move from that to a real database. And for this section here, I want to use a SQL database, a SQLite database to be precise, which is in the end just a single file that you add to your project, which gives you a SQL database without installing any extra SQL tools, which is pretty amazing. Now, the Go standard library, as you can see here, has a SQL package that helps you interact with such databases, though as you learn on that package page, this SQL package must be used in conjunction with a database driver. So in the end, with some other package that implements some database engine specific logic. Now we can take a look at the drivers they recommend here. And you see there are drivers for interacting with all kinds of database services and so on. And I will use this Go SQLite 3 package here, which is a pretty popular Go SQLite package, I'd say. Now on that page, you again learn more about this package, and you find a link to that page attached, of course. And you also learn how you can install and use it. But of course, we're also going to do that together throughout this section. So I'll start by installing it, by running this command in my Go project to download this package so that I can use it with ease in this project here. And then as a next step, we have to initialize that database and establish a database connection. And I'll do that with help of a new subfolder, which I'll name db for database. And in there, I'll add a db.go file. And that file will belong to the db package, and it should import this Go SQLite 3 package. Though here we'll actually need a special import syntax because we'll never directly use this package. Instead, it must be imported here so that Go uses it under the hood. Because we will actually interact with the built-in SQL sub-package, the database SQL package that's part of Go's standard library. Now, to make sure that this import here does not get removed when we save that file, we should add an underscore in front of it, which essentially tells Go that we need this import. It must be part of the final project, but will not use it directly. Instead, this package will expose functionality that's used under the hood by the built-in SQL package. So that's how we should import it. And with that imported, we can then add a function that could be called initDB that is responsible for initializing the database, for making sure that we have a connection and we can work with that database. Now we can initialize this database and set up such a connection by using this SQL package, and then there the open function to open a connection. Now open then, as you see here, wants a driver name as a first parameter and then the data source name as a second parameter. Now the driver name here is SQLite 3. And it must be written like this because that will then make sure that this package is used under the hood, this SQLite 3 package. Now for the data source name, we in the end have to specify the path that leads to the database. And in case of a SQLite database, that is a path to a local file. In this case, I'll name it api.db. It should end with .db, and it will be created automatically if it doesn't exist yet. And all the data will then be stored in that file, but we'll be able to interact with that data in that file by using SQL queries. That's the amazing thing about SQLite. So that's how we open such a connection, and open then returns a pointer to the database, you could say, to the database connection, or actually to a value that also allows us to manage that connection, and it potentially also returns an error. So we should store both values in variables, but for the database, I'll actually create a global variable in this file outside of any function. which I'll name DB, starting with an uppercase character, so that it can be used from outside this package, so that other parts of the app can use this database and can interact with that database. And the type of data here will be a pointer to this database type here exposed by the SQL package, this database struct here. Because that's the kind of value we get back from open, a pointer to that SQL database thing. So, therefore, I want to store the database value that is returned in that global database variable. But as mentioned, we also could get an error here. So we should also handle that and check if error is not equal to nil. And if that is the case, if we were not able to establish a connection, I will actually use the built-in panic function to crash the app, because it doesn't make much sense to continue if we have no database connection. Could not connect to database. Now, actually, thanks to Gin and thanks to its default engine that we started, even if we panic, the server won't crash, but we will get a log that makes it very clear that something very bad happens and that we should probably take a look at this server and fix this problem. So that's what I do here. If we make it past this if check, we have an established connection, and then we can use this db value to manage this connection. To be precise, we can call setMaxOpenCons to configure connection pooling, which is something that's automatically managed by this SQL package and this driver, which controls how many open connections we can have to this database. Because technically, when calling open, we're not really creating a connection. Instead, we're just opening the database, and Go is then able to open connections thereafter. With this setMaxOpenCons method, we then control how many connections can be open simultaneously at most, let's say 10. And that will make sure that later, when the application runs, we don't keep on opening new connections all the time, but instead we have a pool of ongoing connections that can be used whenever they're needed by different parts of the application. And at the same time, we make sure that this pool isn't too big. In addition to setting the max number, we can also set the max idle connection number, which simply means how many connections we want to keep open if no one's using these connections at the moment. And with that, I'm making sure that we have at least 5 connections open at all time, so that if we have an incoming request, it can immediately be handled, but more connections will be opened all the way up to a number of 10 connections if we have more requests coming in and if we need more connections. If we need more than 10, those other requests will have to wait until a connection is available again. So that's how I want to configure this here. And with that, we generally initialize that database. Though one important thing is missing. At the moment, we won't have any tables in that database, and we will need tables in order to store data in there.